we're working on data handling, and I've got a really interesting data handling question here. And you know what it's like if I say it's really interesting. It actually is really interesting. Let me just rearrange that. Writing on Friday and Monday. All right, Kayan. So this week is gonna help a lot, hopefully. Let's see if we can't help you out for Friday's examination. Okay, so data handling. Here we go. So we have some stats from Stats SA. It is the mid-year population estimate report, and this is for 2018. And there's a table below there which talks about the assumptions of expectation of life at birth without HIV/AIDS from 2002 to 2018. So the assumptions of expectation of life, what that means is an assumption, we're assuming how long a person is supposed to live for on average. Okay, so it's life expectancy. Life expectancy is an indicator of how long people live in a certain country. All right, and we've got 6 years of data here, and we've got data for male and female. So these numbers here that you can see for males in the 60s and for females in the 70s, these are how long males are expected to live and how long females are expected to live for a certain year. Okay, very interesting looking at this data. It looks like the ladies are living a bit longer than the men. All right, looks like the girls outlive the boys here, which is actually a common trend, not just in South Africa, but throughout the world. The ladies seem to live longer. Maybe they're just chilled. Maybe they're just more healthy. I don't know. All right, so there's our data. 6 years of life expectancy for male and female. Okay. And here come the questions. Number one, there it is. Oh, sorry, not number one. Number two, I skipped number one. It was a bit too easy for us. Number two, it says, is the data given discrete or continuous? You guys can type in chat. Discrete or continuous, this data, which one is it? Discrete or continuous data? This question often comes up in exams. You can just type it in chat there. Is it discrete or continuous data? Just type it into chat. Don't have to come online. Is it discrete or continuous data in this table? All right, good. We got some answers coming in. Yes, good, good. Yes, it is true. It is absolutely correct. It is continuous data. How do we know? Because continuous data has got decimals and it's in units of measurement. And this unit of measurement we know is time, years. And you can show years and time with decimals. So yes, it is continuous data. All right, very good. So let's just put this answer here. Continuous. All right, very good. Well done. Next question. Identify the year. I'm just going to copy this question and bring it up. Identify the year in which the difference in life expectancy without AIDS between males and females was the highest from 2002 to 2008. Okay. Oh, that should be 2018. All right, so that 2008 should be 2018 because the data is 2002 to 2018. All right, so the difference between the two, I'll put the question underneath here. I'll make some space. Whoopsie. Why is it doing that? There we go.
You did
All right.
say it was on holiday. You did say.
Hey, yeah, it's not me, guys. It's something else. Number three, identify the year in which the difference between these two, the male and female, was the highest. In many words, lots of words that are really unnecessary. They're saying Identify which year, which are these numbers on the left, was the difference between male and female the highest. That's what they're asking here. In which year was the difference the highest? Can you guys see? Can you tell me in which year was the difference the highest? You might need a calculator to confirm. All right. You can kind of eyeball it, but the numbers are very, very close to each other in each column. So we actually might need the calculator to confirm. What do you guys say? Which year was the difference between the two, the male and the female? Was it the highest? You actually can't really easily eyeball this. You've actually got to do some calculation. All right. Any answers yet? I'll give you guys some time. Which year was the difference between the two numbers in the male and the female column the highest? Put 2 marks. It's quite a tricky question for 2 marks because you got to take up some time to get the answer out. Okay, Kayon's suggesting that it was 2018. Anyone else with a view with 2018? Very interesting. Well, what we can do is do quick calculations. So 71.6 minus 64.5, 7.1. That's a 7.1 difference. And now we want to see if we can beat 7.1. So let's go up from the bottom. 71.3 minus 64.5. No. Let's try 70.6 minus 64. No. 70.2 minus 63.6. No. 72.2. That's not going to be 70. No. Yeah, I'd say 2018. Yep, I'd say 2018. So what I'm sure you guys did was you eyeballed it, looking at the gap between the two numbers, and maybe you thought, oh, this gap here looks pretty big. You test it with 7.1, and then we got to go back and check is anything else bigger than 7.1. And you might have to use your calculator for that. It's quite a lot of work actually for 2 marks, but yeah, we can do it. Whoopsie. What happened there? There we go. All right. So yes, 2018 is the answer. Well done. Okay, here comes the next question. Question 4. Write down the modal life expectancy for females. Write down the modal life expectancy for females. I'll put the question up here. Whoopsie. Write down the modal life expectancy for females. So the question is underneath the table. Write down the modal. Now you might be confused by the word modal. Do you know what that word means? We're doing data handling, so it's mean, median, or mode. Which one of those three are we talking about? Yes, well done, Leonie. It's mode. So write down the mode for the ladies, the females. All right, we got an answer. We've got some answers coming in. The mode for the ladies. All right, so we're looking at this one here in the right-hand column. Which one is the mode, or which one occurs the most? I'm sure you guys can see it. If you can see it, put it in chat. So I know you guys are there. Well done. Good. Yes, these two are duplicates. All right. Yes, so those two are the mode. 70.02 is the mode. Very good. Well done. All right, so not too bad. So 70.2 is the mode. Write it down. Number 5, here we go. Calculate the difference of life expectancy for males between 2013 and 2018. All right, let's bring this question up. For males between 2013 and 2018, what is the life expectancy? There's the question underneath the table. What is the difference in life expectancy for males between 2013 and 2018? just put it in chat when you get your answer. The difference for males 2013 and 2018. All right, Ndine, well done. Well done, Kayan. Good. All right, good. Very good. Well done. So the difference between these two numbers here, all right, 64.5 and 63.4. We obviously need to subtract them. And that is 1.1. Very good. Yep. Nice and easy. Okay. Well done. That is the difference between those two numbers. Right, difference means subtract. So we just subtract those two numbers that they're looking for. Okay, let's have a look at the next one. Here's the next question. I'll bring it up. Determine the median life expectancy for males. Determine the median life expectancy for males. Now, is there anyone out there that can explain to me how we do this? Is there anybody? Somebody? Anybody? Yasmin. Right,
Yes.
Yasmin. Hey, Yasmin, how are you?
I'm okay, and you?
Good, thank you. When are you writing your exam?
Tomorrow and Friday.
All right. All the best there. So this data handling should be in your paper one.
No, unfortunately not.
What's in your paper one? Finance?
Um, yes, and percentages and those, like a whole lot of those things.
Oh, okay. All right. How do we determine the median? What is the median?
The median is the middle number.
Very good. So to find a middle number, don't we have to rearrange these numbers in order?
Yes, from the smallest to the biggest.
Okay, so if we go down this list, are they arranged from smallest to biggest?
No.
63.4,
Yes.
63.5,
Yes, I'm
6.
sorry.
You know, it's fine. Yes, they are luckily arranged for us. On the other side, yeah, they're also smallest to biggest on the other side as well. So this works out well for us. Okay, so how do we find the median?
Um, Can't see like, wait, let me count them.
No problem.
4, 5, 6. There's 6 numbers,
There are
right?
six. There are six numbers. What does that tell you?
That the middle one would be probably the fourth one, the fourth number,
Uh,
or
so
the
if it's
third
an
number.
you correct with both of those. So if it's an even data set, so it's good that you count it because if you count the data set, you know there's six numbers. It tells you it's an even data set. And if it's an even
Yes.
data set, it's going to be between the two middle numbers. And you said the third and the fourth. So these two numbers here, it's between those two numbers there. So how do we find it?
I don't know now.
All right, so we take these two numbers, we find the average for them, we add them up. So we say 63.6 plus 64.0 and divided by 2. So 63.6 plus 64 and divided by 2. So it's halfway between the two, so 63.8. There we go. So, Jasmine, you were correct in counting how many there were because you need to know, is it an even data set or is it an odd data set? If it's even, two middle numbers, you add them up and divide by 2. Now, Jasmine, what if it was an odd data set? What would you do then? What if there was another number here, 64.7?
I don't know.
So then
Would
if
you?
it's odd, let's change it like this. if it's 7 numbers, which makes this an odd data set, then you're not going to have 2 numbers in the middle. You're only going to have 1 number in the middle. And one way to find that number is you can cross them off on either side. So cross that one off, cross that one off. One on that side, one on that side, one on that, one on that side, and one on that side. And you end with 1 number in the middle, and that would be your median. So if it's an even data set, 2 numbers in the middle. And then you need to find the average between the two. You add them
Can
up.
I ask a question?
Yeah, of course.
If like, isn't it even and like there's always is there always like 2 numbers? Or can you
Always.
do it the same way like how you do the odd?
No, it's always. So if it's even data set, you're always going to have 2 numbers in the middle. Okay, so if
Okay.
you think about it, there's 6 numbers here. I could draw a thick line between. Whoopsie. I could draw a thick line between the data set, the numbers in that to split the data set. So there we go. That red line there splits the data set exactly in half. There's 3 on the one side and 3 on the other side. All right.
Mm.
So the middle isn't on any of those numbers. It's somewhere in between those numbers. So to find out where between those numbers, we find the average between the two. That's why we say we add them up and divide by 2, because there's 2 numbers. To find the average, you add them up and then divide by 2. Now, if there's an odd data set, so let me add the 64.7 at the bottom, then in actual fact, the middle number, which is the fourth one, obviously let's make it a straight line. The middle number here at 64 is exactly on the middle. So now I've got 3 numbers above that line and 3 numbers below that line. So 64.6, sorry, which is the underneath the red line, is the middle. So it's 1 number in the middle. But in the other case, it's between 2 numbers. You see, so if it's even data set, it's between the 2 middle numbers. If it's an odd data set, it's on the middle number. Okay.
Thank you.
Pleasure. Thanks for your help. I appreciate it.
No problem.
All right. Okay, so that is the median for this data set. I hope you guys all saw that. Okay, so if it's an even data set, 2 middle numbers find the average. If it's an odd data set, it's the middle number. Okay. All right, let's go down to question number 7. I'm going to take these answers here. By the way, you see what I've written here? I've written 7 numbers odd. They're not going to mark that. They don't want to see that. That's in your head. Okay, so this information here that's in brackets is in your head. It's your thinking. They don't want to mark that. Okay, so just that's not to be written down. Okay, you can if you want, but they're going to ignore it or maybe even be confused by it. All right, but I'm going to bring this answer down here. Jasmine, thank you so much for your questions. All right, let's look at number 7. Calculate the average life expectancy for the females. Calculate the average life expectancy for the females. Let's make a space here. There's the question. Calculate the average life expectancy for the females. Now, I need someone to come tell me. Jasmine was brave enough. I need someone else to come tell me. How do I do this? What is the average and how do I work it out? Is there anybody out there? Anybody? Somebody? Dine, I know you know the answer. Yes, come on now. There we go. My man.
Good evening, sir.
Good evening. How do I work this out?
Okay, so sir, okay, so 1, 2, 3, 4, 5, 6. Okay, so there's 6. We count
Yeah.
6. So I'm sure we're gonna do like we did with the male. So we're just gonna add up the 2 middle numbers, and then the answer we're gonna divide by 2.
It's a similar calculation. So that calculation will be added. We wanted to find the average of the 2 middle numbers. So we added the 2 middle numbers up and divided by 2 because there were 2 numbers. But now we want the average for the female. So that's all of these. So we're not going to do the middle 2. To find the average of all these numbers, we need to add them all up, eh?
Oh, the average for all. Oh,
Yeah.
my bad. I didn't read the question
No,
properly. My bad, sir.
that's fine, but you know the method. You
Okay,
know,
so
that's
we're just gonna add all of them.
yeah. Now, I don't know if you can see what
Okay,
I'm
so we're
doing.
just gonna.
I'm writing out a very long sum.
Yes, sir.
Now, ladies and gentlemen, please listen to me carefully.
Oh,
I'm
sir.
writing it. Yeah.
Oh, sorry, sir. No problem. I was just gonna say that we're divided by the number counted, but since you've already done it, then it's
I
fine.
got it there. I got you. Don't worry. Please note. I'm writing the whole thing out just so you guys can see the method. All right. Please do not write this all out. Can you imagine if this data set had 12 or 15 or 20 numbers and you would sit there and write out 20 times this plus that plus this plus that. You don't need to do that. You do not need to do that. Okay. What the marker really wants to see is when you find the sum of these numbers. So that part can be done on the calculator. All right, so I'm going to do that on the calculator. In fact, we don't need a fraction. Let's just do it like this. So 70.1, Dina, just stay with me, eh? 70.1
Yes, sir.
plus 70.2 plus 70.2 plus 70.6 plus 71.3 plus 71.6. All right, so this summation, the answer to this sum is 424. That's what they want to see. So this whole sum does not need to be written out. Please don't write the whole thing out. All you need to do is write 424. They want to see that number. That's all they want to see. Okay. So don't write the whole thing. You're wasting your time. Just write the 424. That's all we need to do. And
Sir?
then, yeah.
I'm sorry to disturb you, sir. Question. What if one of the instructions on the front of the paper says show all working, show all calculations?
Thank you for bringing it up. You're absolutely right. You're absolutely right. Show all calculations. You should show all your calculations as much as you can. But I promise you now, for this calculation here, if you don't, I mean, Kia will back me up, I think. Yeah. If you don't write the whole sum out and you just put the summation, they'll still award you the marks. All right. I walk past students in the examination and I see, in grade 8, this is something that they would actually look for, is that you actually show all the numbers that you're adding up. But grade 11, we don't need to worry about that. They just want you to see that you know that you have to sum the numbers, and they want to see what answer you get. If you're gonna sum all the numbers, you're gonna have to write. You're gonna have to write this out in the next step anyway. All right, so this is fine. Start with this, and then go straight to your answer. So now we're gonna take this and we're gonna divide it by 6. And this is what my calculator says. Dina, you're gonna help me round this off. What does this round off
to? 2 decimals or single decimals, sir?
Always 2 unless told otherwise.
Okay, so the answer is going to be 70.7.
We're looking at the second decimal there, which is a 6. Will that decimal change?
Yes.
That one will, yeah. So the first decimal, which is a 6, will not change, but that second one will change like that.
Oh, shoot, my bad.
No, it's okay. It's okay. Don't worry. You're probably thinking about all kinds of other subjects because you're studying at the moment, probably.
Yeah. It's quite hectic at the moment.
It is hectic. I can imagine you got to switch your brain over to math lit between 6 and 7 o'clock. Must be difficult.
Yeah. But we do what we have to.
Dina, thank you so much for your help, man. I appreciate it.
Thank you, sir, for helping me understand. You helped me jog my memory. Thank you, sir.
No problem. I might call on you just now. We'll see. All right. Another thing I want to show you
No
here
problem,
is,
sir. I'm here.
all right. When we see our answer here, this is an average. Okay. And if we look at the females here, if you do this answer and you get 63.2 for your answer, have a look at the data, ladies and gentlemen. Is 63.2, does it look like an average for those numbers? They're all 70s or 71s. We should be getting 70s or 71s, right? So if you get 63.2 as your answer, a quick glance at the data will confirm if you are doing the right thing or not. Okay, 63.2 is not an average for this data set. So you might need to go and check your calculations if you get something like that. All right. Okay. Thank you, Ndine, for your assistance. Let's move down to the next question. That was question 7. Let's put that there. Question number 8. Draw a line graph. Now, you guys can't do it, so I'll do this for you. Draw a line graph illustrating the life expectancy at birth for the females from 2013 to 2018 and answer she provided. So we got to draw a graph explaining the ladies on this graph paper here. Okay. All right. So 70.1226. So I'm going to just plot these out. Okay, so 70.1 for 2013. And now I'm looking at that mark and the bottom one. It's groups of, there are 5 marks, so it's groups of 2. So 70, wow, it's groups of 2 to make up 2. So 5 marks to make up 0.2, which means half of 0.2 is, half of 5 is 2.5. Wow, this is a horrible scale. But anyway, we're going to do what we can. So that's 70.1. And then 2014 was 70.2. 2015 was also 70.2. Now, when you do this, can I give you a hint? You guys are obviously going to be using pencil or pen. In fact, you should be doing pencil, because if you make a mistake, you're going to be in big trouble. So you should be doing this in pencil. When you plot the points, especially if the graph paper is very bold with lots of thick, dark black lines, draw a little circle around your points just to show the marker, look, those are my points. Okay, you don't have to do that, but it makes it quite obvious to the marker where your points are. All right, so there was 70.1. We go up here, 70.1, 70.2, 70.2, 76, 71.3. So I need a 76, which is up here. And then 71.3, which I'm assuming if I go there, I'm squinting. There we go. And then the last one is 71.6, which is up here. All right, there we go. So there are my points. And they say draw a line graph. So we're going to join this with lines. I'm not going to start at 0. We're starting at the first point. And we just join the dots. Okay. Now, once you've drawn this graph, guys, please do this in pencil in the exam venue. All right, don't do it in pen. Is everything on here? Yes, we got a heading. Our heading is there. Our heading for the y-axis is there. Our heading for the x-axis is there. There we go. Okay, so we're all good. I hope you guys see that. All right. Nice and easy. 7 marks in the bag, and there's 6 points plus lines, a point, maybe a mark for each point here, and then a mark for joining it with lines, guys. 7 easy marks. Okay, let's move on to the next question. Let's see. Woi! Now, you guys, if you were in the matric revision classes, you would have seen they drop in probability questions all over the place. They sprinkle them all over the exam. So here we go. Determine the probability as a percentage of randomly choosing a female with life expectancy blah, 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 of less than 71 years. Determine the probability of choosing a female that's less than 71 years. Now, for probability, we need a fraction. And at the bottom of the fraction, we need the total possible number of outcomes. How many possible number of outcomes do we have here for the ladies, the females? What number should be at the bottom of my fraction, ladies and gentlemen? How many possible options are there? You can just type in a number into chat. Everybody should be typing in a number into chat. How many possible options are there for the ladies, the females? Yes, 6. There are 6 possible. Everyone should have typed in 6. Okay, there are 6 possible. Okay, so in our fraction here, we need to have a 6. Okay, now the scenario says of choosing a lady or a female less than 71. Now that's specific criteria, less than 71. If you look at the data, how many are less than 71? Everyone should be typing a number into chat. How many are less than 71? Good, 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 good. Of the 6, there are, yes, there are 4 that are less than 71. The first 4, very good, are less than 71. So that's 4 out of the 6. Okay, 4 out of 6. All right, very good. Yes, Kayan, very good. So now this probability fraction is your standard probability number. They can ask you to show this as a decimal, leave it as a fraction, a simplified fraction, or a percentage, okay? We need it as a percentage, so we're going to times this by 100 to get our percentage. So it's 4 over 6 times 100. And that gives us 66,666666667, which rounds off to 66,67%. All right. All right. So probability needs a fraction. At the bottom of the fraction, how many total possibilities are there? And at the top of the fraction, the criteria specific to the question. 4 out of the total 6 are less than 71. Okay, put in the fraction and then show it in the format that they want. All right, let's move on. I hope you're all good. Moving on to graphs now. I've got a crack of a question at the end, but I don't know if we're going to get to it. Let's see if we can fly through this section. Study the pie charts below and answer the questions that follow. Percent distribution of 5 leading causes of death by age group in the United States for 2011. The 5 biggest causes of deaths in the US for the year 2011. We got 2 age groups. We got from 1 to 24, the young people. And then we've got, that's Kia's group. And then we got 25 to 44. This is my group, the old people. Okay. We got the young people and the old people. What is the age or what are the reasons for dying? So the young people, sorry guys, but it looks like most of the young people are doing silly things and are dying due to accidents. Okay. The older people, not so much. You see, we got wisdom. This gray in my beard, it's wisdom. All right, we've been there. This is why you should listen to your parents. They've been there. All right, it's wisdom. They're going to warn you because they've been through it. Homicide is next. Not good in the US. Unfortunately for older people, things like cancer are second. All right, suicide is third for the young people, and heart disease, oh dear, is third for the older people. Okay, so there we go. Pie chart showing all this information. Very interesting. Question number 1. Determine the total number of people between 25 to 44 which are dying from accident. Determine the total number of people which are dying from accidents in the 25 to 44 year age group. How do I do this? Somebody help me. Somebody? How do I work this out?
Anybody?
Anybody?
This is
Oh,
not the night for it to be crickets, guys.
I can see Sianda Shange is typing. There we go. 26. Okay, so Sianda, that answer would be correct if the question read determine the percentage. So if these words here weren't there and they said determine the percentage, then yes, your answer of 26 is correct because it's that percentage there. But this question is looking for the number. All right, 26% of the total. All right, so there's the total there. I don't know if you can see it, 113,341. 26% of 113,341 is how many? All right, here's someone that's going to help us out.
Sir, it's me again, sir.
Yes, what do you do?
So, sir, I just typed it on the calculator, 26 over 100 times the total, and then I got the answer. The total is 113, 341. So I said 26 over 100 multiplied by 113,341. And the answer was 29,46866. Rounded off to 29,47.
Okay. Your method is absolutely perfect. Let me just type out on the calculator exactly what you did.
Oh, no, so the answer is wrong. The answer is wrong. Wait.
Why? Why is the answer wrong? What's wrong
Okay,
with
the
your
total
answer?
numbers. Oh, I'm looking at the wrong total. I'm looking at the wrong total. Sorry,
What's
sir.
wrong with your,
I'm
what's
looking
wrong
at.
with it? Which total are you looking at? You got the right total.
I thought the screen was a bit zoomed in, so I saw something else. Now that I zoomed out, I realized I don't know. It was just a minor mistake.
That's fine. So you, the one thing that I wanted to point out to you is some countries, we don't really do it a lot here in South Africa. They use, if you look up at the total there that I've underlined in red, they use a comma to separate the thousands. All right, which can confuse people. All right, so this comma here, if you don't know that, if you don't know that in some countries the comma is used to separate thousands, then you might think that that number is 113,341. When actually
Oh,
the actual fact the number is 113,000. So this is
okay.
113,341 deaths in America for this age group. So it's a very
Oh,
easy mistake to make because we don't know that the Americans like using the comma as a thousand separator. So they'll use a decimal point only to show decimals. We often use commas to show decimals and they laugh at us. So the comma in this number here is showing the thousand separator. So you keep your method. Your method's absolutely perfect, but just go back and remove that decimal there and then just press equals again. Okay, and then you'll get 29468, comma 66. So 29468, comma 66. Now the comma in this number is a decimal comma. All right, this is not for thousands. And Dina, just help me round. Oh, we don't need to round this off. It's rounded off for us, isn't it? But here's my question to you. And Dina, you still there?
yes, sir, I'm still here, sir.
All right, here's my question to you. They want to know how many people. Determine the total number of people. And our answer comes to 29,468,66. How can we have 66 people? Can we have 66 of a person?
Well, you can't have 6 people, so I
Oh,
guess we'll just have to stop at 29.
we'll have to round it off to a
No,
whole.
never.
We'll have to round it off to a whole number. So 2946, and so we'll look at the 8, and will it
Oh my,
change? So the 8 will become a
a
9.
9.
So we're rounding it off to the nearest whole person. Okay, does that make sense?
Yes, that makes sense, sir.
Awesome. Your method was perfect. Just be careful that American comma is for thousands. We don't use that comma for thousands. Your method was absolutely spot on.
Thank you, sir.
All right, that's awesome. Thanks for the help. Any questions about this? Are we all good, ladies and gentlemen? Are we all good in the hood? Are we all okay? If so, we're going to move on to the next question. All right, let's have a look. Number 2, identify, not calculate, identify the causes of death amongst 1 to 24-year-old people that are less than 10,000. Identify them. I need you to identify them. Which causes are less than 10%? Identify them, please. If someone says to you, identify the person, you'll obviously say the name of the person. So when they say identify the causes, you're obviously going to say the name of the causes that are less than 10%. So please identify them. Cancer and heart disease. Keon, very good. Ndine.
So can I please ask, sir?
Yes.
Is it in the age 1 to 24
It
category
is.
or the
Sorry.
age 25
Yeah.
to 44?
Sorry, I didn't bring the question up. It is age 1 to 24, the first one. So which causes are less than 10% there?
Cancer and
Cancers.
heart disease.
Yes, absolutely. Good job. Cancer and heart disease are less than 10%. All other can't be included because it's
Nope.
26.
26.
26. Dina, thank you so much.
Okay. Yes, sir.
All right. So cancer and heart disease, I'm just going to write that down. So we identified them, hey? We have to give their name, write them down. All right, next question. Calculate the difference in the total number of deaths of the two age intervals. I'll bring this question up and I'll pop it here at the top. Mark Sparsi. All right, there we go. There's a question. Calculate the difference in the total number of deaths of the two age intervals. What is the difference in the total number of deaths for the two age intervals? All right, Tato there, fast fingers, got a value already. Leonie, good. You guys are falling prey to the decimal. Don't fall for the decimal. Don't fall for the comma that they have. Remember the comma that they have in these numbers, that comma is not our comma. All right, that comma is for thousands separator. Okay, don't fall prey to the comma that they're showing you there. They're trying to trick you. So it's just 113341. Don't write the comma. 39213. All right, don't write the comma. It's just showing where the thousands are. So 113, but you guys, your method is absolutely fine. 39213. 74128. 74128. Okay, so don't fall prey to the comma trick, the comma trap. That's just the way the Americans like to show their thousands. All right, we don't type it into the calculator. Be careful of that. But yes, your method is absolutely fine. You subtract the two and you get that value. All right, let's move on. I'll bring this answer down. Yeah, there we go. We are looking at, let's see, where did that go? There it is. Number 5, identify again the age interval that has high mortality percentage in high. It should be highest. This word should be highest. Highest mortality percentage in heart disease. Identify the age interval that has the highest mortality percentage in heart disease. So let me bring that question up here to the data. Okay, I'm going to squeeze it in here at the top. Identify the age interval that has the highest mortality percentage in heart disease. Identify which age group, age interval has highest mortality in heart disease. Yes, it makes sense, doesn't it? The old people, my age group, have highest mortality in heart disease. We've got heart disease for the younger people at 3% and heart disease for us old folk at 12%. So yes, the old people. Thank you, Tando, for reminding me. Yes, it's us old people. All right, but don't write old people in your exam. You write the age group that they give you in the diagram, 25 to 44. All right, so 25 to 44 years. Okay, identify the age interval. Remember, this is an interval. It's from here to there, from 25 to 44. So if you write just 25 to 44, you'll be fine. I put in their years because I know Kia always likes to see units. I also like to see units. All right. Next question. 6. Give a reason. So this is not calculate or identify. This is give a reason why the accident percentage for the age group 1 to 24 is higher than 25 to 44. All right. Why do the young people have more accidents? I want to hear from you now, class. Why are you guys having more accidents? Kayan, you couldn't have said it better. Anyone else? Why are young people having more accidents? Yeah, the wisdom from this group.
Right?
You got, yo, the wisdom. You're young but wise. You're young but wise. Young for your ages. You're absolutely right. I couldn't have said it better. Young people are more reckless because young people are still learning from their mistakes. Absolutely. And that's life. All right. So don't feel bad. We all went through it. We all went through it. We all learnt when we were young. We made lots of mistakes. We learnt, and then we got old and told our kids, don't do it. But kids have to learn for themselves. All right. You're young and you're learning from your own mistakes. Yes, that is life. Okay. So those two reasons are absolutely acceptable for this answer over here. All right. Anyone else have anything interesting else they want to add? Those are two very good reasons. Can we take a glance at this cracker of a question? Don't run away. Don't run away. Let's have a look at it. Let's just have a look at it. All right. Let's just have a look at it. Okay. Checking on the list to make sure that people like Tiamo are not escaping now. All right, she's still there. All right, okay. Tiamo still there. All right. Here we go. Question 1. Yeah, we can join the sentence. Absolutely. It's a perfect answer. Let's have a look. A grade 11 math lit class at Ibanda High wrote an examination marked out of 100. The results arranged in ascending order are shown below. So there we go. There are 100. Well, we don't know how many there are. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 across the row, and 1, 2, 3 going down. So 10 times 3, there are 30 students. The marks out of 100 are ranked in ascending order. Okay. Now, the question is, the mean of the data above is equal to 64.2. A learner calculated that the value of C in the above data is 74. Verify that with calculations. How can we check if the missing value C is 74? Whew, guys, this is not easy. Who's got an idea? I told you it was a crack of a question. We're in deep waters now, swimming with the sharks. What do? Do you panic or do you think? What can you do in this situation? What do you do when the sharks are swimming around you? Do you panic and kick and splash? No, tell me, don't do that. If you're swimming in the deep waters with sharks around you, you do not panic, because the human reaction when you panic is to kick and splash. And guess what? Sharks can pick that up and they'll come straight at you. No, guys. Yes, Keon, you got to remain calm. All right. Because if you kick and panic, the sharks pick it up. Do not panic. Let's think about it. All right. First of all, it goes two ways and two ways only. It's either 73 or 74. Yes, we have to. Tando, you are the calmest person in this group. I know that. I know that for sure. All right. Let's pull this apart. First of all, it's the mean. The sentence says it's the mean. Now, how do we work out the mean? All right. This is how we do it. The mean is equal to the sum of the numbers, right, divided by the number of numbers. I don't know if that makes sense to you. It's the sum of all the numbers over the number of numbers there are on the data set. Does that make sense to you? I hope it does. I'm sure it does. Okay, that's how we work out the mean. You sum all the numbers in the data set, you divide it by how many numbers there are in the data set. So the sum of the numbers over the number of numbers there are in the data set. Okay, that is the mean. Now, let's take this equation, and I know I'm using the word equation, which you think is core math, but we can do this. Let's take this equation and put in the information that we have. All right, the mean is 64,2. That's what they're telling us. All right. And then you add all these numbers up, the sum of the numbers. Okay. We can do that. We can sum all the numbers up. I'll write the word here, the sum of the numbers. But we don't know what C is. We're pretending we don't know what C is. Hold on. Keon, 73 or 74. But we've got to verify with calculations, Keon. That we have to show them how. It's 4 marks, eh? So we've got to sum all the numbers and we've got to add C, which we don't know. All right. And we've got to divide by how many numbers there are. There we go. We're starting to fill this equation out now. We're starting to put the pieces together. Okay. Let's take it from here. Now, the sum of all the numbers, I'm going to quickly do that. All right, I'm going to quickly do it. In fact, I don't have time. I'm just going to show you how to do it. All right. The average is 64.2. So let's do this. Let's say 64.2 times 30 is 1926. Minus 73 is 1853. Let's say we added all these numbers up except for C and we got 1853. 1853. All right. So we took all the numbers that we do see, we add them all up and make a sum of 1853, but we don't know what C is. We're saying plus C, and you're going to divide that all by 30 to get your mean of 64.2. But now we have an equation and we need to find out what C is. So we can now use the reverse operations or inverse operations to work out what C is. So the first thing I want to do is get rid of divide by 30. How do we get rid of divide by 30? You can times by 30. That'll cancel that. All right. But you've got to do the same on this side. Okay. So now we've got 30 times 64.2 equals 1926. So 1926 is equal to 1853 plus the C, and we want to know what the C is. So now what we're going to do is we're going to take away the 1853 here. We subtract it, but we also got to take away 1853 here. All right. So C is now on its own, and it equals 1926 minus 1853. So 1926 minus 1853 equals 73. All right. Now, I know what you're thinking, ladies and gentlemen. It's the end of the lesson, but I know what you're thinking. Sir, how can they make us do an equation like this? Equation building and manipulating equations is part of math literacy. All right. The methodology here, we don't really practice it a lot, but how to manipulate an equation and work with an equation, you actually are supposed to know. This is a difficult question, so if you can't get this, do not feel bad. You should be able to get everything else that we did tonight, which is like 90-something% of the marks we've covered tonight. So if you don't get these 4 marks, it's not a train smash. Okay, so it's under what I did, first of all. I said, I've got this equation, and while I'm talking, Kia is going to put up the poll. I've got this equation here. All right, I built this equation. Whoopsie. Oh, let me remove this. Whoopsie. I built this equation because I know it's the mean. I know we have to sum all the numbers. I couldn't sum all the numbers. I could only sum of 1853 of them, plus the C that we don't know, divided by 30. That's the equation for the mean. I need to find the 30. So the first thing I need to do is get rid of the divide by 30. How do I do that? What's the opposite of divide by 30? Times by 30. Divide by 30 and times by 30 cancel each other out. But what you do on the right-hand side, you also got to do on the left-hand side. So 30 times 64.2 gives me 1926. On the right-hand side of the equation, I've only got 1853 plus C now. To get rid of 1853, because it's added onto C, I use minus 1853. Okay, but what you do on the right-hand side, you also got to do on the left-hand side, 1853. And 1926 minus 1853 is 73. Now, Kian estimated it was 73 or 74 because of the numbers were ranked. So she saw it's between 72 and 74. It's got to be in that range somewhere. Yes, you could estimate, but they said you got to show calculations. Okay, you've got to show calculations. Ladies and gentlemen, that is all for tonight.